Myself, Dr. Somir De, teacher in charge and assistant professor of mathematics section under Department of Basic Science and Humanities. This is my lecture number 4 under module number 2. Paper name is Mathematics 1A, paper code BSM-101. This paper belongs to BTech first semester, Computer Science and Information Technology. Topic indeterminate forms and LHospital rule under module Calculus Differentiation. Introduction. Let fx and gx be two functions, then the ratio fx by gx is undefined at x equals to a if ga is equals to 0. If ga is equals to fa is equals to 0, then the ratio fx by gx has the indeterminate form 0 by 0 at x equals to a. But fx by gx may have a finite value as x tends to a. Other indeterminate forms are infinity by infinity, infinity minus infinity, 0 into infinity, 0 to the power 0, infinity to the power 0, 1 to the power infinity. We now discuss some of these forms below. That is in next slide. The form 0 by 0 LHospital rule. If fx and gx be two functions such that both are continuous in a less or equals to x less or equals to a plus h, both are derivable in a less than x less or equals to a plus h, and fa is equals to ga is equals to 0, then limit x tends to a fx by gx is equals to limit x tends to a f dash x by g dash x is equals to f dash a by g dash a provided g dash a not equals to 0. This rule admits the following generalization. If fx and gx be two functions such that nth derivative n minus 1th derivative of fx and n minus 1th derivative of gx are continuous at x equals to a, and nth derivative of x and nth derivative of gx both exist and x equals to at x equals to a, and third, fa is equals to f dash a dot dot f nth derivative at a is equals to 0, and ga is equals to g dash a is equals to dot dot n minus 1th derivative of a is equals to 0, then limit x tends to a g fa by ga is equals to limit x tends to a it should be by mistake it should be x fx and gx limit x tends to a nth derivative of fx by nth derivative of gx is equals to nth derivative of fx at a, nth derivative gx of a provided nth derivative of gx at a should not be 0, not equals to 0. So from it is clear, when we can see your limiting value 0 by 0, then we can apply LHospital rule. This then we have to differentiate fx and gx, and if we get after substituting the limiting value to the function f dash x and g dash x, we can find the value, and this finite value, this will be the answer for this limit. But if I get the same again 0 by 0 form, okay, then this derivative will continue until and unless first derivative, second derivative, third derivative, and so on, until and unless we get finite value, provided lower derivative of gx at x equals to a should not be 0. Now try to understand. Example: limit x tends to 0 e to the power x plus sin x minus 1 by log x log of 1 plus x. Suppose we want to find the limiting value of this expression. Now if I substitute the value e to the power 0, it is 1, sin 0 is 0, minus 1, that is ultimately value becomes 0, and log of 0 x 0, that is log of 1, log 1 is equals to 0, ultimately you have log 0 by 0 form. indeterminate form, log 0 by 0. Now what do you do by using don't forget to mention LHospital rule. By using LHospital, what you do, you have to differentiate this, that is e to the power x derivative e to the power x, sin x derivative is cos x, and one derivative is 0, and log 1 plus x derivative is 1 by 1 plus x. Now again you put x equals to 0, e to the power 0 is equals to 1 plus cos x cos 0 is equals to 1 by 1 1. So ultimately from here it is clear, that is you have finite value, that is 1 plus 1 by 1 by 1, that is 2 by 1 is equals to 2. So this is the finite result, so you can stop the calculation. So this is the limiting value of using LHospital rule, limit x tends to 0, e to the power x plus sin x minus 1 by log x, log of 1 plus x. Okay, next example, x minus sin x by x cubed. Same way, if I put x equals to 0, that is 0 minus sin x, 0 means 0, 0 minus 0 means 0, and x to the power cube 0 means 0. So ultimately 0 by 0 form. Then what do you do? Again, using LHospital rule, you have to differentiate this x derivative is 1, sin x derivative is cos x. So 1 minus cos x by 3x square. Again we apply, when x equals to 0, that is 1 minus cos 0 means 1, 1 minus 1 is equals to 0, and x equals to 0, that is 0 by 0 once again. Again we apply LHospital. Just try to understand, in last problem, in second line we have a finite value, but in this problem, after second 0 by 0 form, again you have to apply LHospital rule. Then again one derivative is 0, minus cos derivative is plus sin x, and 6x. Again you can check, when you substitute the value x equals to 0, sin 0 and 0, again 0 by 0 form. Again we apply LHospital rule to differentiate this, that is sin derivative is cos x and 6x derivative is 6. So now using LHospital rule, now you find the limit, cos by 0 is 1 and 6, that is 1 by 6 is the answer. So from, if I compare question number 1 and this question number 2, just to check, I differentiate only single times, then when I substitute the value, limiting value to the expression, we get the final result. So you can stop the calculation. But in second problem, we can check in 3 times we have a 0 by 0 form. So from here it is clear. So this differentiation will continue until and unless we get finite result. Okay, this is also very good example. Now next example, evaluate x tends to 0, tan x minus x by 1, x minus sin x. First you check tan 0 0 minus x 0, x sin 0 0, x. So ultimately 0 by 0 form. Now again LHospital rule, what you have, there is tan derivative is x square x minus x derivative is 1, and x derivative is 1, and cos derivative is sin x. So if I put x equals to 0, that is what is x square, x value is 1, minus 1 0, and cos 0 is 1, 1 minus 1, again 0 by 0 form. Again you differentiate this, that is 2 derivative is and that is 2 sec x, and sec x derivative is sec x tan x. Okay, one derivative is 0, and this one derivative is 0, minus cos x derivative is sin x. So from it is clear, if I substitute the value 0, so again it becomes 0, and lower part also becomes 0. Numerator part is 0 and denominator part is 0. Again you differentiate uv. So when you differentiate tan x, that is sec square x, that is 2 sec to the power 4x plus 2 sec x and tan x sec square, already know sec x tan x derivative. So ultimately we have 4 sec square x and tan square x. Now again you apply LHospital rule. After differentiate you have this. Now substitute the value, x cos derivative is 1, sec derivative sec 0 is equals to 1, so 2 into 1, and tan 0, so this portion is 0, and lower cos 0 is 1. So from it is clear, that is 2 plus 0 by 1 is equals to 2. So within 3 steps we can get our result. So from it is clear that we should continue our differentiation until and unless we get final result. So this is one form of LHospital rule, that is 0 by 0 form. Another example is the example how to understand limit x tends to a. Now limit evaluate limit x tends to 0 e to the power x minus e to the power sin x by x minus sin x. Okay, process same, limit x tends to 0 to the power x minus sin x e to the power sin x by x minus sin x. If I put x to the x is equals to 0, that is e to the power 0 means 1, sin to the power 0 means 0, that is 1 minus 1 0, and 0 minus 0 0, that is 0 by 0 form. So using LHospital, what you do, just differentiate this, that is e to the power x, e to the power x sin x, e to the power sin x into cos x, 1 minus cos x. Again, if we put x equals to 0, what you have, that is 1, this is 0, then e to the power 0 means 1, e to the power 0 means 1, so 1 minus 1 0 and 1 minus 1 0, again 0 by 0 form. Again LHospital, using LHospital rule, we can see e to the power x, so e to the power 0 by 0 form we have, that is derivative this, that is e to the power x, e to the power sin x cos square x plus sin x e to the power sin x. Okay, cos x derivative is minus sin x, so you have plus, and lower part is 1, derivative is 0, and minus cos x is sin x. So ultimately you check e to the power 0 means 1, sin to the power is 1 minus 1 0, this is 0, that is 0 by 0 form, again 0 by 0 form. Then what you do, again differentiate this, there are so many terms you have, that is e to the power x, okay, that is e to the power sin x, that is e to the power sin x cos cube x. Now they differentiate this, that is e to the power sin x to sin x cos x, plus derivative of this, that is e to the power sin x cos x, then e to the power this sin is fixed, now it is e to the power sin x cos x by cos x. If I substitute the value again by using LHospital rule, that is a, you have to continue the differentiation, that if I put x equals to 0, that e to the power 0 means 1, here it is a 1, 1 minus 1 0, here it is a 0, and here it is a 1, here it is a 0. So ultimately 1 minus 1 0 plus 0 plus 1 plus 0. So ultimately you have 1 and lower part is 1. So ultimately we get finite result. So we can stop the calculation. This is our limiting value. Now, so first part is over, that is 0 by 0 form. Now infinity by second form is infinity by infinity. Let fx and gx be the two functions such that both are continuous in a less or equals to x less or equals to a plus h, and both are derivable in a less than x less or equals to a plus h, and a limit x tends to a fx is infinity and limit x tends to a gx is infinity. Then limit x tends to a if dash x by g dash x equals to a less than infinity, then limit x tends to a fx by gx equals to l. So this is the form of infinity by infinity. But our objective, so if it is another indeterminate form, so we have to apply this concept, this derivative, again you have to differentiate to get the finite result. Now try to understand, very easy. Limit x tends to infinity, 2x square minus 4 by x square plus 2x plus 3, so infinity. So ultimately this infinity by infinity, again you have a infinity form, again you apply LHospital rule, that is differentiate this, that is 4x by 2x plus 2. Again if you put x tends to infinity, then infinity by infinity form, again differentiate by using LHospital rule, that is 4 by 2. So if I simplify, then what we get 2. So the final result, you have to stop the calculation. So this is our limiting value, and result is 2. Next example, if our limit x tends to 0, log of sin x by cos x. This is also very important example. Now here limit x tends to 0, log of sin x by cot x. So log 0 is infinity and cot 0 is infinity, that is infinity by infinity form. If I have infinity by infinity form, then what you do, you have to differentiate by using LHospital rule. You differentiate this log sin x derivative is 1 by sin x into sin derivative is cos x, so cos x by sin x, and cot derivative is minus cos x square x. After simplification, what we have, that is cos square means 1 by sin square x. After simplification, you have cos x by minus cos x. If I put x equals to 0, then cos 0 undefined, and this also cos x. Now we have to minus sin x, cos x. Then again you simplify this, minus 1 by 2, adjust it, and 2 sin x by cos x, sin x into cos x, this cos x after. That is ultimately from here you have sin 2x. So one limit x tends to 0, 1 by 2 sin 2x equals to 0. So this is your finite value. You should stop the calculation. So this is the answer. Another form of indeterminate form is that is 0 into 0 into infinity form. So if you have any problem with 0 into infinity form, then you have to reduce either in 0 by 0 form or infinity by infinity form. Okay, let limit x tends to a fx equals to 0 and limit x tends to a gx equals to infinity. Then limit x tends to a fx and gx is of the form 0 into infinity form. This can be written as limit x tends to a fx by 1 minus gx, that means 0 by 0 form, or you may write gx by 1 by fx, 1 by fx, gx by 1 by fx, that is infinity by infinity form. So from here it is clear that is 0 by 0 form or infinity by infinity form. These are general. Okay, so if you have any, apart from this, if you have any other type of indeterminate form like 0 into infinity form, 0 into infinity form, then we have to reduce it either 0 by 0 form or infinity by infinity form. Then we have to find the solution. Let's see. Evaluate cot x log of 1 plus x by 1 minus x. So limit x tends to 0, cot x, that is cot 0 is 0 infinity, and log, that is 1 in 1 plus 0 by 0, that is log 1 is 0. So from here it is clear that is 0 into infinity, this infinity into 0 or 0 into infinity, because log cot infinity, cot 0 is infinity, and log 1 is 0. So from here you have a 0 into infinity form. Then what do you do? What is our target? Our target to reduce as a infinity by infinity or 0 by 0. What we can do? So from it's a infinity, this is a 0 form. So we may write log a, here log a by b is equals to, you may write log a minus log b formula, and this cot x can be written as 1 by this, that is tan x. So from here it is clear that you have that is, it is 0 by 0 form. So try to understand. So this is our basic objective. So 0, if you have a 0 into infinity form, then you can reduce as a 0 by 0 form. So if I have a 0 by 0 form, so already know how to solve and how to find the result. Same way, by using LHospital law, now differentiate this 1 by 1 plus x plus 1 by 1 minus x. Tan x derivative is sec square x. Now you substitute the value. Can you find the finite result? Just to check, 1 by 1 plus 0, 1 by 1 minus 0. That ultimately here you have a finite result. 1 plus 1, that is 2, and here sec 0 is 1. So ultimately you have 2 by 1 is equal to 2. So this is also another example by which you can this is a process. So if you have a 0 into infinity form, then we can transform as a after changing, you can transform as a 0 by 0 form, then you can find the solution. Next example, evaluate limit x tends to 0, x into log tan x. Okay, and try to understand limit x tends to 0, that is 0, log tan 0, that is tan 0 is 0, so log 0 is equal to infinity. So from here you have 0 into infinity form again. So then what you do, you have to rearrange this in such a way so that we can get 0 by 0 form or infinity by infinity form. So you have to decide according to the structure of the given problem. Now here log tan x you can't transform, so here log tan x, that is infinity, and x can be written as 1 by x. So ultimately what you have, that is infinity by infinity. Last question, you have transform, and that is 0 by 0, and here it is infinity by infinity. Any one form you can switch according to your problem. Okay, now differentiate this 0 by infinity by infinity form. So then you have to apply LHospital rule. Differentiate this log of tan x, that is 1 by tan x into sec square x, and 1 by x derivative is minus 1 by x square. After simplification, what we have, that is x minus x square, sec square x by tan x. So here you have, if when you substitute the value 0, that is 0 x 0 into something means 0, and tan 0 is equals to 0, that is 0 by 0 form. Again you differentiate, simplify this. Okay, that is minus x square, that is cos square by sin square, sin x into tan x, that is tan sin x by cos x. Okay, so ultimately what you have, okay, so from here it is clear that then that is cos square x into sin, after simplifying what you have, 2x square by sin 2x, again is 0 by 0 form. So here you can write directly 0 by 0. So suppose you have a question in your mind, sir, can you start from here 0 by 0, again LHospital, using LHospital rule, differentiation, always you have to remember that your, if you have a simplified form, it is very easy to differentiate. So that's why in this problem I simplify this further. So minus 2x square by sin 2x, sin 2x is nothing but 0 by 0, that is if I put x equals to 0, 0 by 0, so this portion is very easy to differentiation. So that's what differentiate this, minus 4x by 2 cos 2x, by using LHospital rule we have this. Now when I put x equals to 0, so this portion is 0, lower part is non-zero, so that means 0 by minus 4 into 0 by 2, that is 0. So 0 is the answer for this particular problem. Another example, limit x tends to 0, x to the x square log of x square. Okay, so in this problem, that x to the power 0 means 0 and log 0 means infinity. So you have a 0 0 infinity form. Same way like previous problem, log of x square by 1 by x square is an infinity by infinity form. Okay, infinity by infinity form. Now you differentiate this again by using LHospital rule. Differentiate x square into 2x, that is log derivative is 1 by x square into x square derivative is 2x. X's cancel, and here the derivative is minus 2 x to the power cube. After simplification you have, that is x cancel, x cube, that is minus x cube. X square you have, x tends to 0, the value becomes 0. So these are the basic structure of LHospital rule. And so here in this lecture I have discussed, thank you, in this lecture I have discussed 0 by 0 form, infinity by infinity form, and with some different examples, as well as another special form, that is 0 into infinity form. Then if you have a 0 into infinity form, so you have to transform 0 by 0 or infinity by infinity. My request to all of you, you should go through your workout examples of your book, and then you have to collect any one example, any one or two example from your book, and then try to solve by yourself based on this logic. If you can find the answer, so that means your knowledge is clear. Thank you.